Hi, so welcome to 2019 Paper 2 Junior Sir Higher Level for question 5. This is going to be a long one, but if you want to set notes I'm working off, just send me an email at shanetroy@gmail.com, and that email address should be in the description below. So, as I said, this question goes on, there's multiple parts to it. Part A and B are marked together, it's worth 10 marks. It's a coordinate geometry question. The coordinate diagram below shows part of the town where Clea now lives. Each small square in the grid has sides of length 1 centimeter. So basically each one of them is 1 centimeter. Now I've kind of adjusted this so it kind of looks like that is different length than this, but it's just the way I've squashed the image. Okay, so it might look slightly different on the exam paper, more realistic. So if you see here, so the cleaners home, school, and shop. So if you could work out the distance between the two things. In fact, you see there that the school is directly above it. So it's 3 units, okay? So each unit must mean something. I'm not told that yet. And we're asked to write down the coordinates of the shop, the home, the school. So the way it works always with coordinate geometry is the point or coordinate is in brackets, separated by a comma, and there's two coordinates here. Your x is first, and your y is second. Now, it's worth noting, and something if anybody goes on from junior honours onto limit honours, you'll do the x, y, z coordinates, which would describe like three-dimensional space and stuff. In the ordinary level course, you only do x, y. Okay, so you kind of take a step on. It is worth keeping in mind that a coordinate geometry mapping system is just that. It's a way of mapping where things are relative to other things. Often the origin is the most important part, okay, but it just depends on the context and how you want to use it. Anyway, so if we look at what's the first in their shop, okay. So what's the x value is okay, so the x value is the line directly below it. So it's 4, okay. And the y value then is directly across, so it's 4, 5. So 4 on the x, 5 on the y. Okay. Now the answer's there. Where did okay. I should probably read the question properly. A fatal flaw of mine. Now that if let's say I did go ahead and didn't realize, okay, now I'd probably copy it in part B or C or something. They probably take that as a mystery because my answer was right for the school, but I wrote it in the shop area. So that probably would just get a mystery, okay? In that it's the correct answer. It depends on the scheme. Because my other answers would have been right and maybe I would have copped it, okay, later on. But anyway, that's the proper answers there. So the home is 4 on the X, 2 on the Y, and then I did the school already, but so the shop was minus 3 on the X, plus 1 on the Y. Now the part B there says the library is at the midpoint between home and the shop. Write down the coordinates of the library. Now I was just listening to or reading a comment section, something to do with maths in America and Common Core, and somebody was like saying, "I never did my workings and my teacher failed me and stuff." And people might just write down the answer. I wonder, could you? So looking at the library as the midpoint in the home and the shop. Okay, so it's somewhere around here. Could you guess the answer? Maybe. Okay, I would suggest that unless you're really good, okay, and even if you are really good, you're doing an exam. Okay, if you're doing this just for yourself, cool, work away, do it whatever way. But in an exam situation, you're trying to convince the person grading that you get this. Okay. Now, correct answer, no work shown might get full marks, or it might get a deduction. It depends on the marking scheme. Or you might make a mistake in your head or whatever and get the wrong answer. But if you have the working shown, you'll most likely get something. Okay. So I'm sure I've said that before in numerous videos. I don't do this myself when I'm working just to get something done. But again, you're trying to present your best side to somebody. Okay. You don't wear your worst pair of pants or whatever, or dress, whatever you do, on a date. You wear your best set of clothes. Okay. So I'm writing out the formula. Okay. I'm writing out the 2 points. Be careful you're using the right two. So home, okay, and shop. Now it is worth saying here. Let's say you'd gotten the coordinates wrong from the initial thing, they would be accepted as fully correct in any part in the future. Okay, that's very important. It means you won't get penalised for incorrect work in a previous part. So once I've got the 2 points written out, I'm going to label them: first x, first y, second x, second y. Now I'm going to put the number where the letter is in my formula. So instead of the first x, I put 4. Yes, there. Instead of the second x, okay, I put -3. I'm putting in brackets. Probably wouldn't actually affect anything, but just to make sure I don't make a mistake there, I don't forget it. Okay. Then the first y is 2, and the second y is 1. Now we can just go ahead and simplify. I'm going to remove the brackets. I'm going to actually do it all in one go here. But 4 plus -3 is the same thing as 4 take away 3. Plus by minus changes that to a minus. 4 take away 3 is 1. I don't change the 2 on the bottom because 1 over 2 is a half. I can leave it in fraction form. On the y side there, 2 plus 1 is 3. It's written here. And the 2 stays the same. I could write that as 0.5 and 1.5. It doesn't say don't. But it doesn't matter. Well, that'll be an extra step. Why would I bother? Anyway, that's part B. So part C here says work out the distance, okay, from the home to the shop on the diagram. And give your answer in centimeters, correct the 2 decimal places, and show your workings. Now, I've included this formula here. This is the formula from the maths tables, okay? So it's going to go back a step, and I'm going to try to get rid of this fluff here and just clean up the page. Now, it was the home and shop. Okay, so literally the home and the shop. Now, what I could do there is, this is just worth keeping in mind. If I make this into I wish I was using my tablet. Okay, I'm looking for that distance there. That's supposed to be a straight line. Okay, so again, the mouse is just absolutely dressed. I have it all. So that's a right angle triangle. Okay, if I take a very simple version of it here. Okay, that's my right angle triangle. This has a height of 1, so 1, 2, 3, so 7. Okay, a base of 7 there. I could use Pythagoras. Okay, hypotenuse squared. Okay, so h squared equals 1 squared plus the other side squared is 7 squared. 7 squared is 49. 1 squared is 1. So h squared equals h squared equals 49 plus 1, which is 50. Bring the square across, so the height is equal to, you bring something across the equal, it turns into a square root, and that's the square root of 50. Okay, and then the units, wherever they are. Now, that's one way of doing it. You always keep in mind that lots of formulas are adaptations of more basic principles. And this is Pythagoras' theorem. Okay, so this formula here is basically Pythagoras' theorem rearranged and adapted for use with coordinates. Now, personally, I kind of just am so used to doing it, okay? In a sense, it's become the standard method. So I write the formula out, write out my 2 points, label them first x, first y, second x, second y, just like we did with midpoint in the previous part B. Substitute the things in, okay? Now, in one way, you can always substitute them in brackets. That'll help if there's signs, okay? Depends on your level of ability, but this is junior or higher level. So this stuff is bread and butter, okay? If you feel you're getting close to the exam and you're struggling with filling in or using formulas like this, just doing the formula, in one sense, it's worth considering going back to past, okay? Now, maybe you should because it's junior cert, but you are focusing for a while on getting your ability to use formulas down. Then everything else will start to get much, much easier. So anyway, I'm putting in the -3 for the x2 value. That's here. The 4, now that's a positive 4, so it's not going to be affected by the negative there. So I don't need to put it in brackets. The y2 there is 1, so it's fine. And then the y1 is 2. So that's, again, is positive. It's not going to be affected. So in that case, I don't need to put them in brackets. Although to the point there is a rule. I could just do it all the time. But it would add an extra step between these 2 points here. And if I go left to right now, do inside brackets. -3 minus 4 is -7. There. 1 minus 2 is -1. Now go left to right and square. -7 squared is the same thing as -7 times -7. So minus is plus, 7 sevens is 49. And then -1 squared is the same thing as -1 times -1. So it becomes plus 1. What's really going on there is any number squared always turns positive. Okay. And then you're going to square root that. Now I should finish off, just do the addition here under the square root. So 49 plus 1 is 50. Square root of that. Now, in one sense, I could leave my answer as square root of 50. That is the answer. But it specifies that I should leave my answer correct to 2 decimal places. So I'm going to convert that to a decimal. Now, I've only written it to 3 decimal places. So it's 7.071, whatever. The 1 is all that matters. Okay, so the 1 is less than 4, so the number prior to it stays the same. If that number had been 5 or greater, this next number would have changed and went up by 1 unit, whatever. So it's 7.07, and I should put in the units because I should always put the units in. So it's 7.07 centimeters. Well, a lot of marks for effectively using the distance formula. Happy days. Now, part D says the distance on the diagram from the shop to the school is roughly 8.1 centimeters. The diagram is to a scale of 1 is to 2,500. Okay, so obviously the distance there is much different. Work out the actual distance from the shop to the school and give your answer in meters. So if you notice, this is centimeters, this is meters. The first thing I would do is go, well, 1 meter equals 1,000 centimeters. Now, I wonder would that give me the low partial? It might, okay. Although D and E are marked together, but that's given to you in different formats in the maths table, so it's not knowledge you've used, okay. If I do some calculation, okay, I'm going to use the answer here because it's written out, but the ratio I'm given is 1 is to 2,500. Okay, now we know that 8.1 is the distance they're saying from the shop to the school. Okay, so I'm going to increase this side by 8.1. If I do it to one side of the ratio, I have to do it to the other. Okay, it's kind of a fundamental principle. So I multiply the 2,500 by 8.1. Now I put it through the calculator, I get 8.1 is to 20,250 centimeters. That's great. That's the distance. The distance from the shop to the school is 20,250 centimeters. But if I said to you, I'm driving to Dublin, I'm going to drive whatever, okay, centimeters to Dublin, people would think you're mad, okay. You would just say kilometers, okay. So they want you to convert it to meters, which will be more like your whatever, 500 meters from school or whatever. So I say 1,000. Okay. Apologies. 1 meter to 100 centimeters. It's terrible. Okay, I'm making this video very late at night. I should be in bed. Anyway, so 1 meter is equal to 100 centimeters, and so I'm dividing that by so how many hundreds in this number. Okay, so you divide it, and I come out with 202.5 meters. So a hop and a scotch. Right, so part E there says, Cleana walks from the shop to the school. Explain why the distance she walks is probably more than the actual distance from part D. Okay, I have the answers right in front of us, but you're going to try, I suppose, figure out, okay, she walks from the shop to the school. Let's go back and look at the diagram. Even though we've seen the answer, get rid of the fluff here. She walks from the shop to the school. Okay, she walks from there to there. Okay, I think it's going to be basically, you can never get to somebody, you have to walk down the streets, okay? So explain why the distance she walks is probably more than the actual distance from part D. Well, okay, the part D is the answer from part D is how as the crow flies. If you're walking through a town, you're going to walk up and down different streets. Now, if you said that, it should be interpretable. It's always worth keeping in mind with anything in life that somebody else is trying to interpret what you're trying to write and or say. If they can't, they don't understand what you're trying to say. So I often see students write things, and I'm sure in their head it sounds perfectly legit, but to anybody else reading it, or to the marker, grader, which is really all that matters, it doesn't actually make any sense. So be careful what you're writing down, in that you're being like explicit, okay, without being waffly, if that's possible, okay. Now part F and H here are marked together. There's only 5 marks for this, okay. So the coordinate diagram below has the line L drawn from the shop to the school, okay. But if I've been so long since I've done this, I don't know, okay. There's some mistake here. I don't understand what's going on. F and H, and this is F and G. I don't know why I made a mistake or whatever, but the videos are 14 minutes in, so I'm not going to go back and check it too much because I just don't have time. So work out the slope of the line L. Now, that's the line L there. Okay. So the slope of something is the same thing as rise over run. You could use the slope formula. Okay? Totally legitimately do that. Or I could use the rise over run, which is what the slope formula comes from. Okay. So rise over run. Now, if you pick any 2 points or anything on a straight line, so if I took, let's see, if just actually took the whole thing, this whole kind of massive triangle there. So it goes up 4 and goes across 1, 2, 3, 6, 7. So the slope of that is 4 over 7. Okay, I'll see on the next page. Actually, that's what I did, was rise over run, okay, in the marking scheme. I kind of labeled it there. So remember, this diagram here is kind of stretched, okay, so stretched upward and downward. So this looks longer than it goes across, but it's actually the same thing. It's just, again, stretched. So part G then says, find the equation of the line. Now, there's different ways of finding that. The way I'm doing it here is the kind of more traditional method. I'm using the equation of the line formula. I have a slope and 1 point on the graph. I'm using the point -3 plus 1. So I put my plus 1 in there instead of y1. I put my 4 over 7 instead of m. And I put my -3 in here instead of the x1. Okay. So all my numbers have been put in. I put the -3 in the brackets because this minus times minus is going to change that to a plus. Now I think I've done here for space. There's not much space to fill this in. I've brought the 7 this way. Okay. So 7 times y is 7y. 7 times -1 is -7. At the same time, I brought the 4 this way. Okay, that's perfectly allowed. It's just saving time. 4 times x is 4x, and 4 times, now, negative by negative is positive. 4 times +3 is +12. Usually, actually, they say there, they want all the numbers on one side, the x being positive, being first, and then equal to 0. So I'm going to give it the way they want it, okay? So I'm going to leave the 4x here. I'm going to bring everything else to this side, okay? So it becomes 4x, take away 7y. And this -7 becomes positive going across. And +7 plus +12 is +19. That's it. But you could write with the 0 on the other side. That'd be fine. It doesn't make a difference. More. Oh, God. This is a long question. So the next part here is part G. It says use trigonometry and the slope of L, okay, to work out the size of the angle A. Give your answer degrees correct to the to 1 decimal place. So again, this is the marking scheme seems to be, again, that's must be what's happening here. The marking scheme says G instead of H. That could be a typo and just was never fixed. So let's see what's the answer here. So I've taken in the diagram we had in before. Okay, you can in the actual exam be flicking back and forth, and use trigonometry and the slope. Okay, so the slope there is given the rise, okay, over the run, okay, or if that's the angle you're looking for, this is the opposite, okay, and this is the adjacent, okay, and this is the hypotenuse. So tan is the best because these numbers are whole numbers, okay, so tan of an angle is given by the opposite side over the adjacent side. That's what tan is defined as, okay. Remember, every angle has a relationship with the sides. And the 3 relationships that are most commonly used are sine, cos, tan. So the relationship for sine is opposite relating to the hypotenuse. For cos, it's the adjacent relating to hypotenuse. For tan, it's the opposite relating to the adjacent. Okay, so I know what the opposite is. I know what the adjacent is. It happened from the diagram and from finding the slope. So I can put a tan of an angle equals 4 over 7. Then I can access that database. And there's 2 databases for tan, 2 for sine, 2 for cos. I'm going to use the inverse database, okay, to work out what angle in the tan databases gives 4 over 7 as an answer. So the inverse tan, the calculator will access that database, okay, and it comes up, for me, it came up as 29.7, and convention degrees correct 1 decimal place. So I may have, I don't know if it came out cleanly as 29.7, or if I rounded it. Normally, if I'm rounding it, especially with the space I have there, I would show that, but I didn't, and I'm not going to open up my calculator to test it, because look, it's if when you tried yourself, if you had to round it, you had to round it. Okay, so that's part H. Right, thank God. The end of question 5. Okay, so see you on question 6. Thanks a million.